Welcome everyone. We are discussing second order derivative. Today, through this video, I will discuss some typical problem of second order derivative. So look, problem number 1. X equals to y to the power 1 by m plus y to the power minus 1 by m. Prove that x square minus 1 into y2 plus xy1 equals to m square y. This is general problem. So if it is 3, m equals to 3, then it is 9y. These are problem of JEE Main and Wbjee. In competitive exam, options are to be given. For example, x square minus y2 plus xy1 equals, then options are given. So let us consider 1. X equals to y to the power 1 by m plus y to the power minus 1 by m. So x is given in terms of y. So our main aim will be to express y in terms of x. So let y to the power 1 by m equals to a. Therefore, a plus 1 by a equals to x. So we are getting a quadratic equation. A square plus 1 by a equals to x. This implies a square minus x plus 1 equals to 0. So we are getting quadratic equation of a. Now what is a? A equals to x plus minus b square, x square minus 4 by 2 into a. So this one is 2x, this one is 2x, so this is 2x, so this is 2x, so this is 2ax. So 2x plus minus 4x square minus 4 by 2 into 1. So x plus minus x square minus 2. So 2 is cancel out. So what is a? A is y to the power 1 by n. So x plus minus root over x square minus 1. So y equals to x plus minus x square minus 1 whole to the power. So this is our main aim, to express y in terms of x. Now you have already solved this type of problem. Its power is m. So what we are getting, look, y equals to, if we take plus sign, x square minus 1 whole to the power m. Then we take minus and we verify that we get same answer in each case. So what is dy by dx? So m come forward, x into, we have already solved this problem, m minus 1. So derivative of x is 1, half of root over x square minus 1 is half into root over this into 2x. So m of x plus root under x square minus 1 whole to the power m minus 1 into cancel root over x square minus 1. So this is LCM, x plus root over x square minus 1. So finally x plus root under x square minus 1 whole to the power m by root over x square minus 1. So this is my by root over x square minus 1. So you know, next step is to avoid cosine rule. You have to multiply by root over x square minus 1. So my. Now to avoid root over x square minus 1 dy dx whole square, or you can differentiate it, m square y square. So for it, and y this as 1. Next, differentiating again with respect to x. Differentiating again with respect to x. So look, this is by product rule, x square minus 1 unchanged, 2 dy dx into d2y by dx2 plus 2x into dy dx whole square equals to m square 2y dy dx. So squaring we get this one, and you know, in this case if you take square on both sides, then 2 dy dx will be cancelled out. So finally what we are getting, x square minus 1 into d2y dx 2 dy dx cancel, x into dy dx equals to m square y. So look at the final result, x square minus 1 into y, this is y2, xy1 equals to m square y2. So this will be noted, x is given in terms of y. We have to express y in terms of x. Next, now problem number 4. This will be lengthy but not difficult one. Look, y equals to problem number 4. Y equals to x to the power n into this. So x to the power n is a function, this bracket thing is another function. So you have to differentiate by product. So dy dx n into x to the power n minus 1, then a cos log x plus b sin log x unchanged. Derivative of x to the power n. Then x to the power n unchanged minus a sin log x into 1 by x plus b cos log x into 1 by x. So I have also solved this problem where y equals to only this part, x to the power n is absent. Now 1 by x at the denominator, so multiply both sides by x, x dy dx. So this is n into x to the power n, a cos log x plus b sin log x plus x to the power n into minus a sin log x plus b cos log x. Now this one is y. So this is n into y from given relation. So this has 1. So this is y, n y. Now x to the power n into minus a sin log x plus b cos log x. or you can write x dy dx minus ny equals to x to the power n into this. So call it to transferring ny to left hand side. So we are putting value of y. Next, differentiating again with respect to x. So x into d2y dx2 plus dy dx. This is for product group. This is n dy dx. And this is n into x to the power n minus 1 minus a sin log x plus b cos log x unchanged plus x to the power n unchanged minus a cos log x into 1 by x. Derivative of sin minus b sin log x into 1 by x. This one derivative by product. Now x is at the denominator, so multiply both sides by x. So what we are getting, x square d2y dx2 plus x into 1 minus n into dy dx. Dy dx common, 1 minus n. N into x to the power n minus a sin log x plus b cos log x plus, if you take minus common, then it is x to the power n into a cos log x plus b sin log x. So this is again y. This is again y from the given relation. And from 2, you know what is 2? X dy dx minus ny, x to the power n, x to the power n into minus a sin log x b cos. So look, try to use relation 1 and 2 here. So we are getting x square into d2y dx2 plus x into 1 minus n dy dx plus n as it is. Now put value of this from 2. What is 2? X dy dx minus ny and this is minus y. This is minus y. So finally what we are getting? Look. So x square d2y by dx2 plus dy dx common, dy dx into x is common, x dy dx common, x, so dy dx common. So this is x minus nx, and it is transferred to left hand side, so this is minus nx also, and this is minus y common, n square plus 1. So finally x square into d2y dx2 minus, so minus, if you take, this is 2nx, so 2n minus 1 into dy dx plus n square plus 1 into y equals to 0. So So this is our desired result. Look, x square y2, 2x minus 1, this is into x dy dx, into x dy dx, 2n minus 1 into x dy dx, x dy dx, plus n square y. So you correct it, 2n minus 1 into xy1 into xy1, 2n minus 1 into xy1, n square plus 1, so this is lengthy but simple. We have to use value of y and value of x dy dx minus n1. Now look, problem number 3. This is typical problem. So x equals to sec theta minus cos theta, parametric function. So parameter is theta, dx d theta, sec theta tan theta plus sin theta, plus sin theta. So it is sec theta. So tan theta common. So sec theta plus sin theta into cos theta, because tan theta is common. So tan theta into sec theta plus cos theta, sin into cos. Now what is y? Sec to the power n theta minus cos to the power n theta dy by d theta n sec to the power n minus 1 theta into sec theta tan theta n cos to the power n minus 1 theta into minus. So n sec to the power n theta tan theta n cos to the power n minus 1 theta sin. So this will be plus, minus minus plus. So again taking tan theta common, n tan theta common. So we are getting this is sec to the power n theta and this is cos to the power n theta into sin theta tan theta. So sin theta tan theta is cos theta. So n tan theta sec to the power n theta plus cos to the power n theta. So this to be noted. You must write dy d theta in this form. Now what is dy by dx? Dy by dx equals to dy by d theta into d theta by dx. So what is dy d theta? N tan theta into sec to the power n theta cos to the power n theta tan theta into sec theta plus cos theta. So tan theta is cancelled out. Now look, a minus b is given and you have to find a minus b. This is sec theta minus tan theta and this is sec theta plus cos theta. So this step to be noted. So dy dx equals to this. Now we want to express it in terms of x and y, not in terms of theta, because final result is in terms of x and y. So dy by dx whole square equals to n square sec to the power n theta cos to the power n theta whole square by sec theta plus cos theta whole square. Now this to be noted, a plus b whole square. So a minus b whole square plus 4 ab is cancelled. sec to the power n theta cos to the power n theta. It is also sec theta minus cos theta whole square 4 sec theta cos theta. So this is our main aim. Dy by dx whole square is expressible in terms of this is y square plus 4 and this is x square plus 4. So dy by dx is expressible in terms of x and y. So these two is only this one. Now to avoid cosine rule, x square plus 4 into dy dx whole square equals to n square into y square plus 4. Y square plus 4. Now last step. Main aim is to express dy dx in terms of x and y. So differentiate again. X square plus 4 into 2 dy dx into d2y dx2 plus 2x into dy dx whole square plus n square 2y dy dx. So x square plus 4 into d2y dx2 plus x dy dx equals to n square y. So, good. So this to be noted. So this is typical problem. Find ds d theta dy d theta. Then dy d theta in terms of x and y. Then perform second order derivative. So this is to be noted. This one. Now problem number 2. Problem number 2. Y equals to sin log tan x by 2. Prove that y2 plus y equals to cot x. This is also problem of JEE Main. But it is simple problem. You look. dy by dx. Sin x unchanged. Log tan x. 1 by tan x by 2 into sec square x by 2 plus log tan x by 2 into cos x. So, look, log tan x by 2, derivative of log tan x by 2, you know this is sec x. So, let us verify. So, sin x, you simplify cos x by 2, sin x by 2, 1 by 2 cos square x by 2. So, log tan x by 2 into cos x. So this is sin x 1 by 2 sin x by 2 cos x by 2 log tan x by 2 into cos x. So this is sin x and this is 2 sin x by 2 cos x by 2. This is sin x. So log tan x by 2 into cos x. So look, derivative of log tan x by 2 is 1 by tan x by 2 sec square x by 2 this. If you simplify it, you get sin x. So finally what you are getting 1 plus log tan x by 2 into cos x. So for it, given relation as now differentiate again with respect to x. So d2y dx2 equals to derivative of 1 is 0. 1 by tan x by 2 sec square x by 2 into half into cos x plus minus sin x into log tan x by 2. Now we have already discussed it is equal to 1 by sin x. This is 1 by sin x and cos x unchanged. Up to this is sin x. We have already proved it. And what is sin x into log tan x by 2? So what is value of log tan x by 2 into cos x plus this is minus sin x into this. So sin x into log tan x by 2, this is y, this is y. So this one is y, this is y, so this is minus y. So finally what we are getting, this is y2 plus y because 2 cos x by sin x is cos x. In competitive examination, so look, value of y2 plus y is cot x, tan x, cos x, sin x. So what is the answer? Cot x. So today through this video I have discussed some typical problems of second order derivatives. So these are important for competitive exam. So thank you for